Hi everyone, welcome to this class where we are going to be looking at the important motion concepts. So very important class where we'll go through the important concepts in the motion chapter, and I'm going to try and make it very simple and easy for you. So keep your pen and paper ready and let's dive into this motion topic. Now before we begin, I just want to remind you, do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other subjects, do take them and please do share it with your friends. For ICC students, we have physics, chemistry, biology and maths for classes 8, 9 and 10. Once again, do share out our courses with your friends. And if you want to learn coding, we have Python programming, we have Java coding. Both are great languages to learn programming. And we also have physics and chemistry for the Cambridge IGCSE board, which is the international board. So please do share out our courses with your friends and make sure you have subscribed to our YouTube channel. We also have our Facebook and Instagram page. You can follow us there. So do stay connected with Manocha Academy and keep learning. So first, let's start off with the important concept called rest and motion. Can you identify the things which are at rest here and in motion? So let's start with this house. Will you say the house is in rest or in motion? What do you guys think? Very good. The correct answer is, as most of you are saying, the house is at rest. Now, how do we decide that? One simple way is, let's say you look at this stationary tree, right? The tree is not moving anywhere. So we can say that the position of this house with respect to the tree is not changing. So if the tree is at rest, the house is also at rest. Or let's say you're standing near the house, you're not moving. So the distance between you and the house, let's say, is 20 meters and it's not changing. So the house is at rest. Clear? Now how about this car? You can see this car is traveling on the road. So is it in rest or in motion? Obviously the car is moving. That's what a car is for. So the car is in motion. Again, if you compare it to this stationary electric pole, if the car is moving away from it, the distance from the pole will keep on increasing. So if you compare with the stationary object, it is very easy to see, is the object in rest or is it moving away from it or towards it? Then it's in motion. How about if I look at this tree standing in this ground or this park, is it at rest or motion? Definitely it looks at rest. Again, you can compare maybe with some rocks near the tree or some stone lying there. The tree is not moving away, hopefully, from the stone, unless it's a Harry Potter tree, right? So the tree is at rest. So definitely we say the position is not changing. So our tree is at rest. How about the moon, guys? Moon, is it in motion or at rest? What do you guys think? Motion, right? We know the moon is going around the earth is going around the sun. So definitely we know from astronomy or science, we know moon is in motion. So rest is when the position of an object with respect to other objects around it does not change. So this is the important thing, that when the position does not change, then we say it is at rest. Like we said, from this tree, the house is not moving away. House is at rest. Compared to the rock near this tree, the tree is not moving. The tree is at rest. Similarly, motion, when the position of an object with respect to other objects around it, it changes. So always you have to compare it with something, right? To see if it's at rest or in motion. So we compare it with other objects. So when the position changes, we say definitely the object is in motion. You can clearly see from this pole, the car is moving away. Similarly, you can see this bird is flying here. In fact, actually I took this picture. There's this beautiful place in Orissa. Have you guys been to Chilka Lake in Orissa? How many of you have been to Chilka Lake? So a lot of migratory birds used to come to Chilka Lake, but now because there are so many boats over there, not too many birds come. So I can tell you a nice secret place. It is called Mangla Jodi, which is pretty close to Chilka Lake, and you will see beautiful birds if you go in the winter season, right? So highly recommend you guys to make a trip, and they take you on a lovely boat ride. The entire family can go and you guys can see these beautiful birds. So definitely when I've captured this bird, is it flying or in motion? So let's say I took this photograph from our boat. So our boat, let's say, was at rest. So I told the boatman, I want to take this photo. The boat is at rest, but is the bird in motion? Definitely the bird is moving away from our boat. So this is definitely flying. as you can see in the picture here, the bird is in motion. Yes, so when we say that the position is changing with respect to the other objects, and obviously we are measuring it over time, because if you see in a snapshot of a time, it's somewhere, but after some time, so yes, when we compare, we are observing the objects over a certain time. Very good. Now comes an interesting question. Let's say this car is moving. So let's say this family is going on a trip. You can see father, mother, and this boy sitting. The question is the boy in the car moving? Yes or no? What do you guys think? So let's use the definitions that we have learnt. If we look at the mother, and obviously the mother will be saying, right, don't disturb, father is driving, daddy is driving here. But if we look at the mother and she tells, wear your seat belt and keep sitting on your seat. So let's say the boy is sitting on his seat. So with respect to the mother, let's say the boy is obedient and is listening and not doing anything naughty. Is he in motion or is he at rest? With respect to the mother. So with respect to the mother, definitely he is sitting, or hopefully he's sitting and not jumping around. Okay, so we can say with respect to the mother, he's at rest. But let's say a person is standing outside and looking at this boy, and let's say this person is standing on the road. Is the boy in motion or not? Of course, assuming the car is moving here, the car is not at a red light or something. So definitely the person, this observer, will see the car is moving, the father, mother and the son, the boy, they are all in motion. So can you see that this question of rest and motion really depends on the observer? Is the observer the mother, or is the observer a person outside the car? So is it a person inside the car or outside the car? It really matters, because for anybody inside the car, the boy is at rest. He's not moving with respect to you. Imagine you're sitting next to the boy. Both of you are moving together, but he seems at rest to you. But if the person is outside, it appears in motion. Just like you might have experienced it on a train journey. If another train is, moving with the same train, it appears to be at rest. Or sometimes, your train is at rest, another train is moving, it appears you are moving. Have you guys experienced those kind of things? So clearly we can see that rest and motion are relative terms and depend on the observer. So that is the important concept here. So rest and motion, they are relative terms depending on the observer. If I ask you guys right now, are you at rest or are you in motion? What do you guys think? Again, I'm going to assume that you're sitting and watching this class, you're not taking your phone or tablet and walking around like this and watching this live class. Let's say you're sitting at your study table or on your chair or wherever, and you are viewing this class right now. Hopefully you're not viewing it in a car, maybe you are. So assuming you're at home and you're sitting, are you in rest or in motion? What do you guys think? See, very good, most of you are saying at rest. So if we, let's say, compare it to some light in your room or to the wall in your room, you're definitely at rest. But what if I say, if an astronaut is looking at you from outer space and you're doing this class in physics class and he's observing you, are you in rest or motion for him? The entire earth is moving. In fact, I'm also moving right now. Even though it looks like I'm standing stationary, this entire earth is rotating and we are spinning around the sun, right? So the earth is revolving around the sun, spinning around its axis. So really we are in motion. So again it comes to who is the observer. Is it some person in the room or is it, some astronaut outside? So it totally depends on the observer. So you can see there's no real absolute rest or in motion, because the whole earth is moving, so everything is moving actually. So it really depends on who is observing it. So there are different types of motion. Can you guys tell me what are the different types of motion here? So what is the classification over here? When a body moves in a straight line, what is it called? Linear motion or rectilinear motion. Very good. When a swing moves like this, what is this type of motion known as? You have seen the swing. It goes like this, to and fro. Very good. Oscillatory motion, just like a pendulum. It oscillates like a pendulum. How about this bee? Let's say this bee is flying around, buzzing around, zzz, right? So what type of motion is this called? Vibratory, okay, so we are not talking about the vibration of the wings. I am saying the entire bee or this fly. Very good. This is called random motion. Of course, maybe the bee knows where it's going, but for us it looks like crazy, random. It's moving randomly, almost like, you know, a gas molecule. Its motion is random, we can't predict it. What about this wheel? So let's say right now the wheel looks stationary, but when the car is moving, what is the type of motion of the wheel? So when the car is moving, we obviously know the wheel rotates. So there is a rotation involved. But is rotation the only motion? The wheel not only rotates, the wheel moves ahead as well. Yes? Otherwise there is no use of getting the car. If it's only rotating, then that wheel will become like a fan. Like a good example of rotatory motion is a fan. But the wheel is rotating and moving ahead. So it is both rotational motion and linear motion or rectilinear motion here. So we have rotatory motion, and I'll throw in another word, it's called translatory motion. Why did I write translatory? Because maybe the car is traveling in a straight line, rectilinear motion, or it's traveling around a curved path, which is called curvilinear motion. So rectilinear, curvilinear together can be called translatory motion. Okay, so when you have rotatory and translatory, this wheel is said to have mixed motion. So this is clearly a case of mixed motion. Similarly, if you look at the earth is spinning around its axis, it is rotating around the axis. So there is a rotation involved. So there is a rotation of the earth involved, and the earth is going around the sun, revolving around the sun. So once again you can see there is mixed motion. So there are different types of motion. Again, if they don't teach you the different types, it's not important, but you should learn these. So great question, is circulatory and rotatory motion the same thing? What do you guys think? So let me give you an example. Rotatory motion is an example of a fan. Fan rotates. But circulatory or circular motion is, let's say a ball is going round and round. So if you have taken a string and or a stone and you're turning it with the help of a string, that is called circular motion. Or someone going around in a merry-go-round, circular motion. So can you see circular motion means, or circulatory motion, going in a circle. Rotatory means rotating about an axis. So they are different. Now let's talk about the concept of distance. What is the meaning of distance? Very simple definition. Total length of the path traveled. And again, please watch my videos. I've explained it in detail over there as well. So distance means the total length of the path traveled. So for example, if the boy went from A to B and then from B to C, A to B, let's say this length was 3 meters and B to C was 4 meters. What is the total length, what is the total distance traveled by the boy? Can you guys tell me? So very good, we just have to add it up. The total distance is going to be the total length. So of the path traveled is A to B, B to C. So our distance is going to be 3 meters plus 4 meters. So that's going to be 7 meters. Total length of the path traveled. As simple as that. What is the meaning of displacement? So distance everybody knows, okay? The total length of the path traveled. Displacement is something which is very specific to physics, because normally we say, okay, what is the distance of your house to my house? But displacement means the shortest distance from the initial to the final position. Please remember this definition, because if there's ever a confusion, you can go back to this. So displacement once again means the shortest distance, note the word here, shortest distance from initial to final position. So let's say again the boy walks from A to B, B to C. Let's apply the definition here. What is his initial position? Initial means starting position. So clearly this is his initial position, A. Very good. So this is the initial position of the boy. Now this boy walked 3 meters to B and 4 meters to C. What is his final position? Clearly it's C. But imagine the boy didn't go this way, right? Imagine you told the boy, why are you going this way? Why don't you take the shortest path and reach there quickly? So what would be the shortest path from A to C? Can you guys tell me? Is this really the shortest path? Or would it be, something like this? Or maybe something like this? What would be the shortest path? It's very simple. You just have to draw a straight line from A to C. That's it. The shortest path is the straight line from A to C. Yes, in this case it happens to be the hypotenuse of the triangle, but basically the shortest path is a straight line. So it's as if a bird was flying from A to C. That's why we say as the crow flies or as a plane flies, it will take if it was to take the shortest path, it will be always a straight line. Clear? So if you guys have to calculate the displacement here, can you guys do that for me? Some of you already thinking of the answer. So it's not given here, but let's say it's given that this is 90 degrees. So AB is perpendicular to BC. Clearly we can see we have a right triangle here, right angled at B. So what will be this distance AC? Let's apply Pythagoras theorem. So we know that AC square is going to be equal to AB square plus BC square. Hypotenuse square is square of the sum of the square of the other two sides. So we can just plug in the values here, 3 square plus 4 square. So we know AC square is 25. The hypotenuse AC is going to be 5 meters. Done. So this is going to be our displacement. Now let's say we want to find the speed at which the boy is traveling. So whenever we come to speed, it is what? Time is also now involved. Time matters. Just like we know, time is very important. We shouldn't waste time, right? You may not realize it when you're young, but later when you get older, maybe older as me or older than me also, then we realize the value of time. Okay? So that's why we say that we shouldn't waste time. We should use time. That doesn't mean working all the time. You should keep time for relaxation, time for your friends, for your family as well. I don't mean to say don't waste time means keep working. Then you'll become a robot. But you should know the value of time. Those who know the value of time, you will do well in life because you understand that how utilizing time is important and you should not be wasting it. Anyways, coming back to physics. So what is the speed? How can you calculate it? It's distance divided by time. So the question is, how fast is this boy going? Speed means how fast is he traveling here, right? So for that, that's why distance divided by time, because if he takes less time, faster. Time is in the denominator. So let's say in this case, we are given that the time the boy took from A to B, B to C was 2 seconds. So what is his speed going to be? We saw earlier the total distance traveled is 3 plus 4, 7 meters. Time is 2 seconds. So it's going to be 7 by 2, 3.5 meter per second. Units is very important in physics. Okay, please don't write 3.5. Are you talking about 3.5 rupees, dollars, meters? Meter per second, distance divided by time. Like I talked in the units class, you can easily derive the unit, meter per second. And this is the SI unit. Meter for length and time is measured in seconds. So just like you have speed is distance by time or rate of change of distance, you also have velocity, which is rate of change of displacement. So whenever you have this word rate, means divided by time. For velocity, we use displacement. Okay, displacement once again was the shortest path from initial to final position. So remember, this was our displacement. So what will be the velocity of the boy here? So displacement we had found was 5 meters. So it's going to be 5 meters divided by 2 seconds. Velocity, we usually use the symbol V. For speed, we don't use the symbol S, because what is the symbol of displacement? So normally distance, you can write D, but usually the symbol of displacement is actually S. So that is why speed, we just write speed, and velocity as the symbol V, 2.5 meters per second. Now one important thing is, does the answer end there? So this is one important thing where we need to come back and compare distance and displacement, that in distance, we are just talking about the total length, the direction doesn't matter. But in displacement is a vector quantity, so direction matters. In which direction is the boy going? So here we should not just say displacement is 5 meters, we also need to specify direction, because now we are coming to the concept of vector quantities. Vector means something which has not only value, magnitude, but it also has direction. So what is going to be the direction of this? Can you guys tell me? What is the direction here? So if we consider the normal geography stuff, we know that this is north, this is south, west and east. So the boy is going from here to here. So what will you say? Displacement is 5 meters in the northeast direction. You can see this is north, this is east, so he's gone northeast. So very good, we'll write 5 meters northeast, NE. Many times you'll see in the answers or we ignore the direction. That doesn't mean it's not there. Displacement is a vector quantity. It has both magnitude and direction. Distance just has magnitude, only value. But here many times you'll see direction is not specified. It doesn't mean it doesn't exist. We are not specifying it. But if they give you all this, boy travels to the east and to the north, you must, in your complete answer, if it's possible, you must specify direction. Okay. Sometimes direction could be, towards the right or towards the top, whichever way, but you are giving a direction. Speed, again, easy to remember. Speed, is it a scalar quantity or vector? So easy, because distance is a scalar, time is also scalar. We cannot say the class will end in 20 minutes to the south. Doesn't make sense, right? Or 20 minutes to the north. Time is a scalar quantity. So displacement, time, both are scalar quantities. So if you're dividing two scalars, obviously you're going to get a scalar. So again, speed has only magnitude, only value. Magnitude means value. Unit is there. Please don't write only 3.5. Unit you have to mention, but there is no sense of direction. But velocity, V for velocity, V for vector. Velocity, just because it is displacement by time, it's a vector by scalar, definitely it has direction. It is a vector quantity. So what will be the direction of this velocity? Can you guys tell me? Again, if you use these same directions, if this is north, south, east and west, what will be the direction of velocity? Can you guys tell me? Clearly you can see it is towards the northeast, because it will have the same direction as displacement. Time doesn't have any direction, so it's displacement by time. The answer is going to be 2.5 meters per second to the northeast. So guys, if it is possible for vector quantities, please specify direction, because that is your complete answer. Now let's try this question. A boy goes from his home to school and then comes back home. If the school is 2 kilometers from his home, find his distance and displacement when he returns home. So let's imagine, always it's good to draw a diagram. So let's imagine this is his home. So the boy goes from home to school. If the school is 2 kilometers from his home, so again, since nothing much is given, let's say he's traveling like this. So we'll just take it to be a straight line here. So 2 kilometers. He's going to school and then he comes back. So first it says find his distance and displacement when he returns home. So what is the distance this boy has traveled? Can you guys tell me? So clearly distance is going to be 2 kilometers plus 2 kilometers. He has returned back. 4 kilometers. That is the total length of the path traveled, 2 plus 2. Now the question is, what is his displacement? Is it again 4 kilometers? What do you guys think? Whenever there is confusion, remember the definition. What did the definition say? Shortest path from the initial to the final position. What is the initial position of the boy here? His home. This is the initial position of the boy. Final position, he goes to school, comes back. So initial position is this one and final position is this one. So what is the shortest distance from initial to final position? Clearly you guys can see the shortest distance is going to be 0, because he is back. So yes, it's possible. Total displacement is 0. 0 kilometers, because he is back to his initial position. And here, you don't even have to give direction because it's 0. Is it clear? So this is important. And also note that since displacement is the shortest distance from initial to final, it's always going to be less than the displacement is always going to be less than distance, or distance is going to be more than displacement, because displacement is the shortest path. Well, here since he was back home, displacement is 0. Now let's go on to some more concepts of motion. One is called uniform motion. What does uniform motion mean? When a body travels equal distances in equal intervals of time, then we say that it is uniform motion. Please read the definition carefully. when the body travels equal distances in equal intervals of time. So let's understand with the help of an example. Let's say the car is moving like this, and our time interval from here to here is, let's say, 2 seconds. So we are observing the car like from 0 to 2 seconds, then again 4 seconds later. So again after 2 seconds we observe it, and once again after 2 seconds. Okay, so when it starts off at 0, we have observed it at 2, 4 and 6 seconds. Let's say from 0 to 2 seconds it travels a distance of 10 meters. Again from 2 to 4, or over the next 2 seconds, it travels a total distance of 10 meters again. Again from 4 to 6, or the next 2 seconds, again it travels 10 meters. So by this definition, do you guys think this car is in uniform motion? Yes or no? Because the definition says in equal intervals of time. So we have taken the time interval as, let's say, 2 seconds. So after every 2 seconds, or with every 2 seconds, we are saying the car is traveling 10 meters. So do you guys agree that this car is in uniform motion? Yes, because every 2 seconds it is traveling, every 2 seconds it is traveling the same distance, 10 meters. So definitely the car is in uniform motion. Now based on this example, will you guys agree if I say the car is traveling at uniform speed or constant speed? Is it at constant speed? If yes, what is the speed of this car? Absolutely right. So what is the speed of this car? It is traveling 10 meters every 2 seconds. So if we measure the speed here, so if we look at the speed in this first 2 seconds, we can say it is 10 by 2. So 10 meters by 2 seconds, which is 5 meter per second. Again over the next 2 seconds, the speed is 5 meter per second, 10 by 2. Again for the next 2 seconds, 5 meter per second. So in very simple words, uniform motion means traveling at constant speed. And now the time interval need not be only 2 seconds. You can make the time interval 1 second, 5 second, 10 second. But as you keep making the interval smaller, if it's traveling the same distance, that means it is definitely traveling at the same speed, because you can keep making the interval 1 second, 0.1 second. So every 0.1 second if you measure, let's say it travels the same distance, so the car is at uniform speed. Clear? So this is the meaning of uniform motion, traveling at constant speed. But there is one more detail. Usually the strict definition of uniform motion is not only traveling at the same speed, traveling in the same direction. Okay, so traveling in the same direction. So let's say this car is going towards the east here. Okay, so 5 meters per second towards the east, towards the east, towards the east. So if I say it is moving at constant speed and in the same direction, what is speed with direction known as, guys? What is speed with direction? What do we call that? Speed with direction means velocity. Very good. So speed with direction is called velocity. So we can say the strict definition of uniform motion is constant velocity, as you guys can see here. Fantastic. So uniform motion is nothing but an object moving with constant velocity. If you remember this, you have understood the concept. That means it's traveling at the same speed and in the same direction. Sometimes again we ignore the direction, we just consider constant speed. Obviously uniform motion has its opposite, which is called non-uniform motion. When a body travels unequal distance, look here, unequal distances but in equal intervals of time. Why we keep the time interval equal? Because that is in our control, our measurement. The distance traveled by the car is not in our measurement, it's in the driver's control, right? But we keep the time interval equal, otherwise it becomes very confusing. If we first measure 1 second, then imagine 5 seconds, then 3 seconds, then 2 seconds. Do you guys understand? It's going to get confusing. So let's say we measure every 2 seconds or every 1 second, whatever. Okay. So in this example, let's say we measure the car's distance every 1 second. So we are going to keep the time interval fixed as 1 second. So from here to here, let's say this is 1 second time. Again from here to here, the car traveled for 1 second, and here again. But when it traveled from here to here, let's say it moved only 2 meters. But when it went from here to here, let's say it moved 10 meters. But when it went from here to here, it moved 4 meters. So can you guys see what is happening? In equal time intervals, sometimes the car is moving slow, sometimes it's going fast. Again, sometimes it's going slow. So can you see that it is covering unequal distance in equal intervals of time? You guys agree? So what will be the speed of the car here? If you look at the speed of the car in the first second, how much is it? Distance divided by time. So it's going to be 2 meters per second. What is the speed here? 10 by 1, 10 meters per second. Here 4 meters in 1 second, 4 meters per second. So can you guys see? Here is the speed constant. In non-uniform motion, is the speed constant? The answer is no. Sometimes it's slowing down, sometimes it's speeding up. So non-uniform motion means not constant speed, or if we care about direction also, we say velocity is not constant. Okay, so clearly it is changing here. Now normally when you travel by bike, car, bus, are you normally in uniform motion or non-uniform motion? What do you guys think? So I'm in Calcutta. Calcutta has a lot of traffic. Obviously you can imagine the car is not going at a constant speed. Sometimes it's slowing down in traffic. When there is a little bit of space, the car goes faster, we press the accelerator. So clearly you can see typically the thing is the cars or the vehicles are always in non-uniform motion because the speed is continuously changing. It is traveling unequal distance in equal intervals of time. Uniform motion is like an ideal case, constant speed, or more specifically constant velocity. Constant velocity means in same direction, because it has to keep the same direction, and if it is same direction means the body is traveling in a straight line. So that is why we talk about this concept of average speed. Why? Because as you can see, the speed is changing. So what will I say? What is the speed of this car? Is it 2? Is it 10? Is it 4? It's different at different time intervals, or if you look at the speedometer, it is changing. Speedometer measures the instant speed at that particular time instant. But since it is changing, then we talk about average. So what is the definition of average speed? We say we don't care about the speed at this 1 second, this 2 second, no, because it's constantly changing. I want one number. So what am I going to do? Total distance traveled by this car divided by the total time. So can we guys work that out? So remember we said in this 1 second, so here's another 1 second and another 1 second here. So it traveled 2, 10 and 4 meters. 2 meters here, 10 meters here, 4 meters here. So can you guys find the average speed for me? So what is the total distance traveled by this car? 2 plus 10 plus 4, 16 meters. What is the total time? 1 plus 1 plus 1. We have measured it over 3 seconds. So 16 meters by 3 seconds. So what is the answer going to be? 5 1/3, right? 5 3s are 15. 5 1/3. 1/3 means 0.333. Normally in physics you don't write fractions, you write decimal answers. So it is 5.33333 and so on. Normally you will round it to 1 or 2 decimal place. So it's good to write till 2 decimal place. So I'll write 5.33. Is this answer correct? Is it complete? Don't forget the units, guys, please. So the units is going to be meter per second. So that is the concept of average speed. So normally, whenever you're traveling by car, bus, whatever, or you're going by a train, aeroplane, we always talk about average speed because these guys are non-uniform motion. Speed is changing. So it makes sense to say what is the total distance, total time, divide that, and now you get to know the average speed of the vehicle. So just like you have the concept of average speed, you will also have the concept of average velocity. Just replace distance with displacement. So total displacement divided by total time, as simple as that. Okay. If the body is traveling in the straight line, then distance and displacement are same because it is in a straight line. So average velocity is total displacement divided by total time. Now if the velocity is changing at a uniform rate, so let's say some car or vehicle is increasing its velocity at a uniform rate. So let's take an example. Let's say initially, so initial velocity we denote by u. Let's say initially the car was traveling at 5 meters per second and it keeps increasing its velocity to 15 meters per second. Let's say over the course of 10 or 20 seconds. So what is the average velocity in this case? So if the velocity is changing at a uniform rate, so it is uniformly increasing, not suddenly, or slowly increasing and then suddenly increasing. Uniformly if it is increasing, what will be the average velocity? We can use this simple formula. Just take the average of the initial and the final velocity. So that's all you have to do here. You just substitute these values. It will be 5 plus 15 by 2. So 20 by 2, 10 meter per second. But please note, we can use this special formula only in the special case where velocity is changing at a uniform rate. So this is a special case. And this is the general formula. General formula, special case. Okay. So general formula you can use always, total distance by total time. This is u plus v by 2. So let's take a look at this question. It says a man is walking on a circular track of radius 7 meters. He takes 1 minute to complete half the circle. Find his average speed and average velocity. So come on, I want all of you to try and please draw a diagram. Don't be lazy. In physics, it's very important to visualize the sums, to visualize the questions. So please draw a diagram and let's solve this question together. So what does it say? Man is walking on a circular track of radius 7 meters. So radius of the circle is 7 meters. Let's mark that. Let's say this is O, the center of the circle, and this is the radius. So we can say, let's say the radius is 7 meters. He takes 1 minute to complete half the circle. So what does that mean? Let's say the man is here at point A and he walks like this and completes half the circle and reaches B here. So does everybody agree that this is half the circle or a semicircle? This is what the question is saying. He completes the half the circle and the time taken is 1 minute. So we can write time is 1 minute. We need to find his average speed and average velocity. So come on guys, try this out. See, it's very important. Draw the diagram, write down the data clearly. So now you can easily visualize the question. So let's work out what will his average speed and average velocity be. Always use the formulas. So let's write down first the formula of average speed. What is it? Average speed is going to be the total distance divided by total time. Okay, very simple. The total distance traveled divided by the total time. Now what is the meaning of total distance? The total length of the path traveled. What is the length of the path traveled here? This semicircle, this path AB along the arc, so along the circle, semicircle. So do you guys agree it's going to be half the perimeter of the circle? If you had completed the full circle, it would have been the full perimeter, but this is the half, it's a semicircle, so half the perimeter. So can you guys tell me what formula should I use here to find the total distance? So total distance is going to be, if you had completed the full circle, the perimeter or the circumference of the circle is 2 pi r, but this is half of the circumference, so it's going to be pi times r. Distance traveled is along the circle, so you have to use circumference formula, 2 pi r by 2, so pi r. Now you just substitute the value. Since radius is given 7 meters, we can conveniently use pi as 22 by 7 because the 7 will cancel. If you use 3.14, it's going to be more complicated. So let's do that. 22 by 7 times 7, 22 meters, clear? So we have got the total distance. Total time given to us is 1 minute. So what is his average speed going to be? Average speed is going to be 22 meters divided by, should I do 1 minute here? If I want to calculate his average speed in SI units, what should be the unit of time? Seconds. So it's going to be meter divided by seconds. So let's convert that 1 minute. 1 minute is how many seconds? 60 seconds. So simple. So we are going to do 22 divided by 60 seconds, which is basically 11 by 30. So can you guys calculate that for me? How much are you getting here? Yes, it's 11 by 30, but don't leave it as a fractional answer, right? So normally in physics, we don't write fractions as the answer. In maths, that's fine. So here, or even this kind of sum in maths, you will end up with a decimal answer. So please do the division, don't be lazy. So what are you getting? 0.3666, right? It's continuing. So typically we round the answer correct to 2 decimal place. So this is very important. A lot of students make a mistake here. If I want to round it to 2 decimal places, I need to look at the 3rd decimal place. Okay. If you want to round till 2 decimal, please go to the next decimal. So what is my 3rd decimal place here? 6. 3rd decimal place is 6. That means, should I write the answer as 0.36? No. The rule is, if that next decimal place, which is the 3rd one here, is 5 or more, then you add +1 to the previous digit. Okay, because it is 5 or more. If it was 0.362, then you could have ended it as 0.36. But if it is 5 or more, which is here, it is 6, I need to add 1 to the previous digit. So it will become 0.3637. So this is basically going to be 0.37 meter per second. Please round your answer to the correct to 2 decimal place. Don't leave it as 0.36. That's not a good way to end the answer. Now, how do you find his average velocity? Once again, use the basic formula. What is the formula of average velocity? Can you guys tell me? So formula of average velocity is total displacement divided by total time. So what is the displacement of the man? Remember, he started from A and ended up at B. So initially the man was here and finally he is here. The easiest way to remember displacement is, it is the shortest distance from initial to final position. What is the initial position here? He's at A. What is his final position? At B. So what will be the shortest distance from A to B? Very simple. You just draw a straight line from A to B. So this is the displacement of the man. And we know that this circle has a radius of 7 meters. So if OB, the radius is 7 meters, OA is also going to be 7 meters. So can you guys tell me what will be the displacement? Excellent. It's going to be the diameter of the circle. Very simple. Remember, displacement is shortest distance from initial to final position. So what is the total displacement? Diameter of this circle. 7 plus 7, 14 meters. Done. So let's write that here. So total displacement of this person is 14 meters. What is the total time? Time is the same, which was given here. 1 minute, which is basically 60 seconds. Why am I converting to seconds? We want to be in SI units. Remember, that is why that unit class was very important. We want to write our answer in SI units. So displacement in meters, time is in seconds. In SI, that's how it is, the units are. So let's go ahead and substitute. Average velocity is therefore going to be 14 meters divided by 60 seconds, which is basically 7 divided by 30, right? But we shouldn't end the answer in a fraction. Physics teachers don't like fractions, okay? So please do that division here and find the final answer. So one smart way to divide is do 7 by 3 and then divide it by 10. What is 7 divided by 3? 7 divided by 3 is nothing but 2/1/3, which is basically 2.3333, right? But there's another divided by 10. So you can see that the answer here is going to be 0.23333, recurring, so on. Again, I told you, you should typically end it correct to 2 decimal place or correct to 1 decimal place, whatever you're doing in school. Usually the schools say that we should solve till correct to 2 decimal place. So we need to look at the 3rd digit here. The 3rd decimal value is 3. Now that is less than 5. So we do not need to add anything to the previous digit. Is it clear? You do not need to modify your previous digit. So just copy it down and the final answer is going to be 0.23 meter per second. Please make sure you guys are taking care of the units when writing and writing your answer clearly in this decimal place. Other important thing is, some of you might be thinking, but velocity is a vector. Why didn't we specify the direction? Sometimes it's okay if no direction is given in the question. You don't have to write to the right or towards A, B. That is implied here. But if they specifically give things like north, south, east, west, then you should certainly include your direction in the answer if it's given in the question. See, this is exactly what is explaining you. We again rounded it off. What is the rounding off rule? If that third decimal, so if you are rounding to 2 decimal, you need to look at the third decimal. If the third decimal is 5 or above, see here the third decimal place is 6, so it is greater than 5. That is why I added 1 to the previous digit. But in this case, the third decimal place is below 5, less than 5. If it's 5 or more than 5, you add 1. If it is less than 5, you do not change the previous digit. You do not add 1 to it. Okay, so there we approximate 0.2333 as 0.23. But if that value is bigger, then we will change the previous digit because it's a bigger value, right? So here, if it's 5 or more, then we add 1 to the previous digit. Is it clear? Physics is all about practical stuff. So let's talk about practical measurement in a vehicle. So let's say, you are making a road trip like this. So you are traveling, let's say, from this point, and your car made a journey like this, and you reached here. Okay, so how will you practically measure the distance, displacement, speed and velocity of your vehicle? I've discussed this in my videos as well, so please think, how will you do this practically? So you started from point A and you ended up at point B. So how do we measure the distance? Distance means the total length of the path traveled, how much the car actually traveled on the road. And there is an instrument to measure that, that is called an odometer. So distances are measured using an odometer in the car. There is a small reading on the dashboard or in the motorbike or in the buses. There in the dashboard, just behind the steering wheel or close to it, you will see there is an odometer. So for example, when you started the journey here, the odometer reading, let's say, was 5,000 kilometers. This means before starting here, your car has already traveled 5,000 kilometers. And let's say when you reached here, the odometer reading was 5,020 kilometers. So can you tell me how much distance your car has traveled? Very simple. You just have to subtract the two odometer readings. 5,020 minus 5,000. Final odometer reading minus initial. So clearly the distance traveled here is 20 meters. Very simple. But how do you calculate the displacement of the car? Displacement is always the confusion because we don't use it in our everyday life. We say how much distance we have to travel. We never say what is your displacement, right? But how will you calculate that? What do you guys think? So for displacement, an important thing to remember is revise the definition. What is displacement? The shortest distance from initial to final position. So the car was initially at A, now it is at B. That means we are talking about drawing a straight line from A to B and measuring this distance. So this is really the displacement. Along the red path, this is the distance. So can you guys see the difference? Which one is shorter? Displacement or distance? Which one will have a lesser value? Clearly displacement, because the definition itself says shortest path from initial to final position, as if your car was going straight along this road, or if there is no road, suppose it is flying in the air, going like a helicopter or like an aeroplane or like a bird flies, right? So shortest distance from initial to final position. So that you cannot measure from the odometer, because odometer gives you the actual distance the tires, the wheels traveled, right? So how do you measure that? Practically. So one smart thing is you can use the map here, because normally in the map you have seen it always says, there's a legend in the map which says, for example, 1 centimeter is 1 kilometer. So there's the scale in the map. So what will you guys do? You are going to take a ruler here. So please take a ruler, place it like this from A to B, and you measure this distance on the ruler. Check what is the length from A to B on the ruler. Okay, so just use a ruler like that, measure this length, and let's say it turns out to be, so you measured this length, and on the map, let's say this was 15 or 14 centimeters. So obviously displacement is not 14 centimeters. The map says 1 centimeter is 1 kilometer. So therefore we can say our displacement is basically 14 kilometers. Do you guys agree? Because 14 centimeters will equal to 14 kilometers. So you can use a scale like this, or suppose you're using Google Maps or some, so you use a real map like this or a Google map, digital map, and there you can measure what is the length along the map, and then you use the scaling factor given in the map. So that's how we can practically measure our displacement. Now, how do you practically measure the speed of your vehicle, guys? What do you guys think? So how do we measure the speed of our car? Let's say you're going by this car, this red colored car. So a lot of you are thinking of speedometer, right? Because you have seen there's this instrument in the car called speedometer. But what does speedometer really measure? It measures the speed at that instant. So at right now. So if you're looking at the speedometer, it will tell you the speed of the car right now. 5 seconds later, now, right? That means the speed at that instant. So you can imagine when the car started, what was its initial speed? 0. I hope you're not jumping into a moving car, right? The car has been started. Let's say your parents are driving the car, so they've just started the car. The speed is 0 meter per second or 0 kilometer per hour. Then slowly the car picks up speed. It might slow down in traffic, right? Or it may again pick up speed if the road is empty. So clearly you guys know the speed of the car is constantly going to change here. Yes? So can we really talk about, will a speedometer reading make sense? Because if you tell your friend what speed did you come by? Oh, I started at 0 kilometers per hour or whatever, let's say meter per second or 0 kilometers per hour. Then I went to, our speed went to 10 kilometers per hour, then 20, then a few seconds later we were at 30, then again we came back to 20. He'll say, I'm getting bored, okay, because you are giving me too much data. Because your speed as expected is going to change. It's not going to go at a constant, 30 kilometer per hour or whatever, 10 meter per second. It's not going to be at a constant speed. So what makes sense over here? If your friend wants to know, hey, what speed did you come to my home? Average makes sense because the value is constantly changing. So average will give him an idea, okay, did you travel fast or slow? Right? So here average speed would make sense. Now how will you measure average speed, guys? Very simple. How do we measure it practically? The average speed is going to be the total distance you have traveled. So let's say this was 20 meters divided 20 kilometers divided by the total time. How do you guys practically measure the time? So simple. You check your watch when the car started and you check the watch when you reached. So let's say, you traveled 20 kilometers here total and you took 30 minutes or half an hour. Just use your watch, or stopwatch is even more accurate, or a simple watch. So let's say you took 30 minutes, half an hour. So what is your average speed? 20 divided by half. You can change this division into a multiplication. So make it 2 by 1. So what is the answer you're getting? 40 kilometers per hour. Can you guys see that? So the final answer is going to be 40 kilometers per hour. That's it. Similarly, how will you find the average velocity? Same thing. Total displacement divided by total time. So if you say average velocity, it's going to be the total displacement by total time. Total displacement here is 14 kilometers divided by half an hour, 28 kilometers per hour. There you go. So very simple, you can practically do this stuff. So next time when you're, going in a journey, I would encourage you, if possible, definitely look at the speedometer, this odometer, all of this. So where is it located? Let's say in a bike or in a car. So here, can you see? There is some reading given over here. This is called an odometer, or we say odometer reading. So here it says 10180 kilometers. That means before this, or at the start, this car has traveled 10,180 kilometers. Okay. And then here you can see this is the speedometer, which will give you the instant speed of the car. This is called the speedometer. This one actually measures the RPM. So the rotation. So this is called the tachometer, the revolutions per minute of the car. So this is not so important for us. We mainly look at speedometer, which will give us the instant speed at any instant, and odometer gives us the total distance traveled when you subtract the two readings. Yes, so for your interest, I can write this is the tachometer, revolutions per minute of the wheels in the car. Now let's talk about the concept of acceleration, and please watch my videos also on acceleration. They are given in your course. So what is the meaning of acceleration? Whenever you hear this word acceleration, what do you think? Something going faster and faster, right? Accelerating. So in physics terms, what is the meaning of acceleration? It is the rate of change of velocity. So mind you, we are not saying speed, we are saying velocity. What is the difference between speed and velocity? Speed is a scalar, it doesn't have any direction. Velocity is a vector, it has direction, like 20 meters per second towards the east. So we are specifying the direction. So we can say, well, speed is velocity is speed with direction. So please remember, acceleration we always write in terms of rate of change of velocity. Of course, if we ignore the direction, then we can use the speed values also, same thing, right? Or the body is traveling in the straight line, distance, displacement are same, speed, velocity are same. Okay. So acceleration is the rate of change of velocity. Whenever you see this word rate, it means you are dividing by time. So acceleration is change in velocity divided by time. What does this mean? This we can write the formula. The final velocity, change means final minus initial divided by time. Because please remember, in physics, maths, change always means final value minus initial value. Just like I say, what is the change in your bank balance? Your final bank balance, or what it is today, minus what it was, let's say a month back. Here, same thing, v means final velocity, u means initial velocity. So change in velocity is v minus u divided by time. So we can see how fast the velocity is changing. But one important thing here, when we say change in velocity, does it always mean speeding up, increasing in velocity, or could it be decreasing velocity? What do you guys think? Very good. It can be both. Acceleration is a very interesting term. It always looks like something is going faster and faster, but it can mean going slower and slower also. So please remember, this change could be a positive value if v minus u is greater than 0, right? So that means speed is increasing. Then it is acceleration. So we can say, note here that acceleration could be positive. So basically this means velocity is increasing. Velocity is increasing. Or acceleration could be negative. Then the velocity is decreasing. So final velocity is less than initial velocity. And when acceleration is negative, there's another special term used there. Do you guys know the term? What is it called? We call it negative acceleration or retardation. So this is known as retardation. Yes, very good. Retardation is also sometimes known as deceleration. You might see that word, though that is more rare. Usually we call retardation or deceleration. So is acceleration a scalar or a vector quantity? What is the difference? Scalar means it has no direction, it has value, magnitude or value, but no direction. Vector quantity means it has both magnitude, value and direction. Because acceleration involves rate of change of velocity. Remember, velocity is speed with direction, it's a vector quantity and it's divided by time. Time is a scalar. So naturally acceleration has the same direction as change in velocity. So acceleration is a vector quantity. So acceleration, like velocity, is a vector quantity. So let's practically understand the formula and try a question. A car increases its speed from 36 kilometers per hour to 72 kilometers per hour in half a minute. Find the acceleration of the car. So please try this question. So very simple, use the acceleration formula. We know the initial speed of the car is 36 kilometers per hour. So we can say the initial speed here is 36 kilometers per hour and it accelerated in half a minute. It went to its final speed of 72 kilometers per hour. So V denotes final speed, U denotes initial speed. Again, remember we said acceleration is rate of change of velocity. Here we are using speed, which basically means we are ignoring the direction. So don't worry, it doesn't mean you cannot work with speed numbers. It basically means direction is ignored. So here initial speed is like initial velocity and final speed is like final velocity. Okay. Now what do you guys do? If you guys apply the formula, A equals V minus U by T. So final velocity is 72 minus 36 divided by half a minute. But you can see we are getting some weird units, kilometers per hour per minute. This isn't looking good, right? So what do we need to do? These units are very, very confusing. So when you have this kind of situation, like you have some kilometers per hour, you have something in minutes, usually best to convert everything into SI units and get the answer. So let's do that. So we are going to convert our initial velocity or initial speed into SI units. So it is 36 kilometers per hour, which means 1 hour. Now if you convert that 36 kilometers into meters, it's 36,000 meters. 1 hour is 60 times 60 seconds. So if you work it out, all of this is getting cancelled and we are getting 10 meter per second. So this is one simple way to do it, but there is a shortcut which I have discussed in my videos. You can directly multiply by 5 by 18. So if you're converting kilometer per hour to meter per second, directly multiply by 5 by 18, 5 divided by 18, you'll get the answer. If you're doing meter per second to kilometer per hour, multiply by 18 by 5. As simple as that. So everybody please do this. So 36 kilometer per hour, if you simply multiply by 5 by 18, you will directly get the meter per second value. And you can see it will give you 10 meter per second. So it's a nice shortcut. Same thing, do that for the final velocity to convert kilometer per hour to meter per second. So this is going to be 72 times 5 by 18, which is going to give us 20 meters per second. Are you guys getting it? Similarly, we have to convert our time to seconds. So half a minute is how many seconds? Half minute is 30 seconds. So guys, what is the acceleration of the car? V minus U by T. Let's solve it now. So A is going to be equal to V minus U divided by T, which is basically 20 minus 10 divided by 30 seconds. So we are getting 10 by 30. We can cancel the zeros here. So what is 1 by 3? 1 by 3 is basically 0.33333, again recurring. So what did I say? To round it off to 2 decimal place, look at that third decimal place. It is 3. It is less than 5. So we don't have to change anything to the second decimal place. So final answer is going to be 0.33. And what is the unit of acceleration? Meter per second divided by second. The velocity, change in velocity is meter per second divided by second. So it's going to be meter per second square. So there you go. That's our answer. So main thing in physics is to write the formula, take care of the units, make sure you have done the unit conversion, and you will easily get the answer. And don't forget to round off to 2 decimal places or 1 decimal place, whatever your school recommends. So hope you guys enjoyed this class. I'll take any questions if you guys have it, and do check out the other courses. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. For the CBSE students, for ICSE students also, we have physics, chemistry, biology and maths for classes 8, 9 and 10. And if you want to learn coding, we have Python programming, we have Java coding, and we have physics and chemistry for the Cambridge IGCSE board, which is the international board. So please do share out our courses with your friends. Make sure you have subscribed to our YouTube channel. You can also follow us on Facebook and Instagram. So stay connected with Manocha Academy and keep learning.